start off this video with a challenge problem from the last video. We've got a free body diagram right here. Now, we are going to break up this force F here into its components. So this is a force of 10 newtons. We've got a vertical component of 10 times the sine of theta, so that's going to be 5 newtons. Horizontal component of 10 times cosine of theta, that's going to be 5 square root of 3 newtons. Now, this block is only going to move if the coefficient of static friction, or I should say the force of static friction, is less than the force of gravity. Alright, so the force of static friction is going to be mu times the normal force. So that's going to be 0.5 times the normal force on this block is going to be 5 square roots of 3. So that's going to be 2.5 square roots of 3 newtons. The force of the earth on this block is going to be the weight of the block, so 50 newtons. Right, because its mass is 5 kilograms times 10 meters per second squared is 50 newtons. Alright, so let's sum our forces in the vertical direction. Alright, so upwards we've got a force of 5 newtons. Downwards we've got the weight of the block, so that's going to be 50 newtons. Alright, so this block currently, it's very clearly going to be moving downwards. And the force of the earth on this block is definitely greater than the force of static friction. So we're going to be using the force of kinetic friction. And that is going to be 0.2 times the normal force. So we've got 0.2 times 5. Is going to give us just the square root of 3 newtons. Alright, now if this block is going to be moving downwards, that means we can safely say we've got a force of friction acting upwards on the block. So that would also be plus square root of 3. Now we want to make sure that the block is still moving downwards with this force of friction acting upwards on it. So we take 5 minus 50 plus the square root of 3, and that's going to give us, I should say, approximately 43.268 newtons downwards. So that means the force of friction is definitely pointing up. It's not static, it's kinetic, so choice A is the correct answer here. Alright, I'll let you read the problem, and I would like you to have a go at it on your own. Okay, so there is a more proper way to solve this problem that you should definitely do if you see it as any type of free response question. So to start, we draw a free body diagram for each block. So this is going to be our 2m. We have a normal force, force of the earth, or you could say weight force, force of gravity, and a force of tension. Because the pulley has no mass and no friction, we have a uniform tension. And now this is going to be our 3m. Here we again have the same force of tension because this pulley has no mass, and we have a force of the earth. Alright, next you have to define a positive direction. Typically, that would be your positive direction. And now we sum the forces on each block in the direction of motion, so don't really worry about the normal force and force of the earth on block 2. So we're going to sum the forces on block 3. And that is going to equal the force of the earth minus tension, right, because force of the earth is pulling down in the positive direction. And then we divide by the mass 3m. Actually, we shouldn't divide yet. We should just set that equal to ma, and the mass of this block would be 3m times the acceleration. Now we're going to sum the forces on block 2 in the direction of motion, and we just have the force of tension, which is going to equal 2ma. Now what you have to do is know that critical piece of information that the tension is uniform. So we are going to substitute this value for tension in up here. So that's going to give us the force of the earth minus 2ma is going to equal 5ma. Right, you can add the 2ma, and then you get force of earth equals getting a little ahead of myself there, plus 3ma, add, and you get the force of the earth equals 5ma, and that will give you the acceleration of the system to equal the force of the earth divided by 5m. Alright, so we know the force of the earth is equal to the weight of that block. So we can just substitute in a 3mg, m's cancel, and you can replace this with the acceleration of the system as being 3/5 of gravity. And the reason we just replaced the force of the earth with this block is because we got that variable from summing the forces on that 3m. Alright, now there is a much easier way to do it, and this one you can use on like a multiple choice exam. So I'm going to clear this work a moment. So what you're really doing is looking at the two blocks as, to say, more of like one object, but not quite, more like the system itself. So you're going to sum the forces on the system, and this becomes much easier once you start dealing with friction on the surface between like the 2m and the table. So what you do is you say, what is making this system accelerate minus what is making the system slow down or inhibiting some acceleration. So what is making this system accelerate? And that would be the weight of that 3m block, right? Because it's dangling. So you would say the force of the earth on block 3. We don't have anything that's not causing it to accelerate. If you had friction, this is where you would put minus F. And we know F equals ma, so this is going to be equal to the mass of the system, which is 5m times the acceleration. Right? You replace F sub E3 with 3mg equals 5m times a. Divide both sides by 5m. Your m's cancel, and you get the acceleration again as being 3/5 times gravity. Alright, so here's our second problem, and we want to find m2. So the first thing that we should do is define a positive direction, and let's just do that in the direction of motion. So this will be our positive direction here. Now the next step would be to sum the forces acting on m2. So we have a weight force that pulls down on M2 in the positive direction, and that is equal to M2G, because weight equals mg, mass times the gravitational field strength. And then we also have a force of tension that pulls upwards, slowing down its acceleration, and we said that equal to ma or m2a. So with this, we could solve for m2, but acceleration is not one of our given variables. But we can get a substitution for acceleration by summing the forces on m1. So the only force acting in the direction of motion for m1 is the force of tension. So F equals ma, tension equals m1a. We can say then that acceleration equals tension over m1. And then we substitute in that here to get m2 times tension over m1. So now I'm going to multiply both sides of the equation by m1. And let's make a little room here. So that will give us m1 m2g minus m1t equals m2t. Alright, so the next step is going to be to get m2 on one side of the equation. So I'm going to add m1t and subtract m2t from both sides. So if you factor out m2 from that, you'll get m2 times m1g minus t equals m1t. Alright, and then if you divide both sides by m1g minus t, you'll get the answer to be m2 equals m1t over m1g minus t. So if you had values for each of these variables, you could plug them in and get your value for m2. So hopefully you're able to get the answer on your own. This will be our last problem before I give you the challenge problem for this video. So this may look intimidating. We've got 3 masses, 2 pulleys, which should be connected to the table, like that. Alright, so we want to find the downward acceleration of m1, and it's actually not as difficult as you might think. So I encourage you to pause the video, try it on your own, and then come back and see if you got it right. Alright, so the way we're going to do this is by defining direction of motion to be positive to make it the easiest. Alright, so the acceleration of m1 is going to be the same as the acceleration of the system. So let's do this problem the easy way by thinking what makes the system go, what increases its acceleration. And that would be the weight of m1, so m1g. And then next, what slows the system down? Well, first of all, we've got friction, right? If the system is accelerating counterclockwise, then the force of friction will be acting clockwise. So remember, the force of friction is the coefficient times the normal force times m2g minus m3g, right? Because m3g is being pulled down like that by gravity. Now, A equals F over m. M is the total mass of the system. Alright, and notice there's no tension in there, right? When we're considering the system, we are basically considering it to be like this. And notice that tension is internal to the our system, so it's not really going to be in our equation. Now we can simplify. I'm going to pull out g, then we're left with m1 minus mu m2 minus m3 divided by m1 plus m2 plus m3. And that's the answer for this problem. Alright, here is the challenge problem for this video. Remember to think of the 2 block plus mass, smaller mass m system as a whole when solving, and the solution will be on my Instagram page about 24 hours after the release of this video, link in the description, or you can find the video solution at the beginning of our next lesson, which will be on inclined planes.